The LBT210 solubility tester is easy and safe to use, modular with up to 8 test options, packed with feature-rich software providing full traceability. Test your components, substrates, paste, flux or wetting forces. The LB210 provides accurate and reliable results every time.
Welcome to the ASYS booth here at SMT Connect. Delighted to be joined by Marcus Wilkins. Nice to see you again, Marcus.
Likewise, Trevor. Good to see you.
So we're constantly moving down this journey towards smart factory, lights out, as they say, and we're seeing probably the most advanced example of it that I've seen on the show floor, which is a machine here that's going to do, is going to last for about 20 shifts. It's a router. Please explain to us a little bit about the concept behind it and how it works.
Yeah, the new router, it's an inline system, is the first out of our new series of machines coming out, hopefully in the next couple of years, that are so-called smart. We are going through a lot of effort to collect more data in the spirit of Industry 4.0. Sharing data is only possible when you have data, so we went through a great effort to have more of the I/O link sensors in the system, on the gantries, on pneumatics, so we can get all and retrieve all the information. Make it smart also means we need to analyze, so we normally calculate certain response time, how long a gantry takes from A to B, and then trigger not only static maintenance, for example, after a shift of operation or after 5 hours, but we trigger maintenance when it's needed, depending on when the system tells us to.
So it's not interrupting production or anything like that?
Correct, yes. So the other big effort is make the machines more autonomous. So in this case, as you said, we're going to last a full 20.5 shifts. That means an operator is only loading router bits. The system itself can pretty much pick grippers and change over between different products based on the recipe that's been downloaded. So an operator doesn't have to tend after the machine as often anymore.
So it's automatic changeover of programs, materials. That's automatic changeover too.
Yes, materials obviously, so the best case would be a batch size 1, which typically doesn't happen in real life, but is technically possible and feasible. So the machine can not only adjust the width, load recipes for the spindle and the DIN file obviously, but can also pick the right gripper, pick the right bit that is in the system, and then process the entire batch of boards and then change over to the next product.
Right, great. So all of this of course is monitored offline, I'm assuming, and there's all sorts of alerts come if it starts to drift out of spec.
Yes, so if you're part of the Pulse family or you're using Pulse system, for example, you get all of the alerts on your tablet or on the smartwatch. But also now there is a digital twin running on an app, a tablet, so you can remotely monitor what the machine is actually doing. So it's following the gantry movement, so you have a real live view. Instead of standing in front of the machine, you're remotely placed, and you can still monitor the tool.
Okay, so that's certainly a big step forward. So 20.5 shifts. Do you see where do you see this going from here? I mean, this is a router you're using, which is a fairly straightforward machine. What's the next step you think in automating this factory?
So the next step is really to see still if we can eliminate some of the operator influence making mistakes or remove the operator altogether on the path to the dark factory. One big stepping stone in that is the incoming material receiving station. So we spend a lot of time developing something that allows us to not only scan a delivery node versus individual reels, but then pretty much apply our own unique ID label to the reels instead of using the supplier one, because everyone has its own, flavor and so on and so forth. So we do that on an automated island. You just pretty much open the box that came in with FedEx, load the reels once, and then after that we take it with all the different features like X-ray scanning, component counting, if you want to use the same island also for the return from the SMD line in regards to the reels.
Right. Okay, so all that system is being automated as well.
Yes, and then of course in a perfect scenario you have all the reels now relabeled with your unique IDs. You can put them back into maybe dry storage, our dry tower for example, or bring them directly to the line where they are needed in real time.
Okay, great. Okay, so Marcus, another thing you have here on the booth is you have an RFID system, which is used for identifying materials used in the process, and also for the operator. Let's take a walk across and have a look at that.
Sounds great. Let's go.
Okay, so Marcus, we're standing here beside one of your intelligent systems that's using RFID identification. It's checking a number of different parameters within the printer here in this case, and checking it against the job specification. Tell us a little bit about how that works.
So traditionally, the operator would scan in a certain sequence of different tools that are used for the production. For example, a jar of paste, for example, a squeegee set, maybe a stencil, and so on. But the issue here is if I get distracted as an operator, I could possibly load the wrong jar into the system. So to avoid that, our RFID setup control now has pretty much the ability to use RFID tags. So the advantage here is that only when everything is mounted inside of the machine, then the machine will verify the setup.
Right, so it won't allow the operator to actually process the board until it's been verified.
Correct, and that has now the ability to eliminate any setup error because we only read what is inside and mounted in the machine. Right. Yes.
So the parameters it's checking the correct stencil is loaded, it's checking the paste is correct, it's checking the squeegee blade is correct. Any other parameters?
Up to 10 different IDs can be verified. Some people want to verify tooling. If you use the IPEG, for example, maybe the glue dispense syringe, for example, maybe a paste syringe. So up to 10 IDs can be verified per recipe.
Right. Okay. Great. So that's a way of helping to verify the process. Now you have another RFID system, which is another security barrier, if you like, where you use a key fob to actually log the operator in. Why are we using that and not just some sort of simple password system?
Yeah, so as everyone knows, there's different user levels on almost all the HMIs of all the machines out there. The issue is after a while, the password is like common domain and it's publicly known and so on. So the issue here is that if I'm the operator and I'm changing a recipe, I can key in as the supervisor and just get it done. So we want to eliminate that, again, removing the operator mistake out of the equation. So here we're using the key fob to pretty much log me into the system. And I think the hurdle for me as an operator to give someone else my key fob is a little higher than just having the password communicated to someone.
Right. So another level of security there. So that's great. It seems the good thing about this is keeping the operator involved.
Yes, if there is still an operator, yes.
Yeah, of course. Anyway, Marcus, thank you very much for joining us today. It's great to catch up.
Likewise. Thanks, Trevor.
Okay.